All right. Chapter 16, Lesson 1. This is Tolbert's class, Chapter 16, Lesson 1, if you're listening to this. Oh yes, ladies and gentlemen, we're going to be talking about how these elements want to get it on, so to speak. Chemical bonds. You need to be writing this, ladies and gentlemen. Chemical bonds is the attractive force that holds atoms and ions together when atoms transfer or share electrons. You need to know that these bonds are like flexible springs. In fact, ladies and gentlemen, this here is a test question. These bonds are like flexible springs. They can bend, and sometimes they break, sometimes they don't. You need to write this in your word map. This is one of these words that is not in your word map that you need to include now. The chemical structure is how the bonded atoms are arranged. Here you have the common cube known as NaCl, or salt. Look at how it's kind of situated just like you're used to seeing it. It's a cube. Look. Boom, 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 boom. But it's three-dimensional. Check it out. There it is. So that's why it's cubic. So the structure shows you how it's going to look in real life as well. The bond length is an interesting concept as well. The bond length is the distance between the nucleus. So I've got a nucleus here, and I've got a nucleus here. This distance is known as the bond length. So that can change the basic structure or how it looks. The bond angle, very important. Check this out. This is a water molecule. And water molecule is situated to kind of look like a mouse. You have this part here being the oxygen, the two ears of Mickey Mouse being the hydrogen, given the nose for oxygen, hydrogen, hydrogen. This bond angle is about 105 degrees. So here we go. You need to know chemical bond is, what chemical structure is, what bond length is, what the bond angle, and there's some other things you need to also know. You need to remember that a mixture is different from a compound because each item in the mixture keeps its own properties. Like trail mix. Trail mix has nuts and berries and all this, and the berries don't become nuts, and the nuts don't become chocolate all of a sudden. So a compound contains the same elements in the same proportions. All right, there's going to be a quiz you're going to take, ladies and gentlemen. It's called the Basic Quiz number 1 for Chapter 16. Molecules. Chemical formula tells you the ratio of the atoms in the element. So H2O means I have 2 hydrogen for every 1 oxygen. Or, check it out, HCl, 1 hydrogen for 1 chlorine. Why do they want to bond at all? They want to bond to become stable. They want to bond so that the outermost energy level is full of electrons. In this first example here, this is not full. It's got some gaps here and that outside. This one here, as you can see, there are no gaps to fill. So, in the second example, it's happy. It's stable. The first energy level can hold, and the magic numbers are, can hold 2 electrons. The second can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. Very happy. Let's get on a little bit further. Remember, they either want 2, 8, 8, or 18. based on these magical numbers that we wrote also in our periodic, on our periodic table, or in our word map. These are the magic numbers. 2, 8, 8, 18. First energy level can hold 2 electrons. The second can hold 8, third 8, fourth 18. They want to be moving around like this, even if it means losing an electron, gaining an electron, or even sharing electrons. Here are some key concepts. In class, I'm going to show you these videos, but I'll show you the information about ionic bond, a bond between ions with different charges, or covalent bonds. This is bonds between where you're sharing electrons, or metallic bond. Metallic bonds is when you're carrying and sharing in a swarms of electrons. Do all elements bond? You already know. No, all elements don't bond. You can recall that the noble gases are noble because they're inert. Group 18, they don't want to bond with anything. They have the most electrons they can have in their outermost energy level, and they are very happy. Okay, we also wrote these numbers on our periodic table. These are called the oxidation numbers. These are the numbers if your element becomes an ion. This is the charge of the ion it likes to become. Everybody here likes to become a +1, a +2, +3, plus or minus 4, and negative, negative, negative. Ionic bonds are when you're going to be giving an electron away, where you become an ion. Check that out. You see how it's transferred over there? Sodium gave the electron to chlorine. Sodium was short, wanted to give away one, while chlorine wanted to gain one. This bond causes something known as an ionic bond. When they do that, it becomes, check it out, those charges drop, and there it is, it becomes normal table salt.